Hi everyone, let's work on the review together. Question number 1. Find the perimeter and area of an equilateral triangle with side length of 10 inches. So we have a triangle ABC and the sides are called side A opposite angle A, side B opposite angle B, and side C opposite angle C. This is an equilateral triangle. That means all the sides are equal to each other. They are 10. And of course, we know that the angles are also going to be equal to each other. So 180, which is total of all the angles, we divide it by 3, we get 60. That's the measure of each angle. Now, to find the perimeter, we just need to add up all the sides. So 10 plus 10 plus 10, which is 30. That's the perimeter of this triangle. To find the area, we're going to use this formula 1 over 2 times A times B times sine of angle C. So that's side A, side B, and the angle between them. So we're using this formula. So it's going to be 1 over 2 times 10 times 10 times sine of 60. Now, if we use our calculator, we can find the answer, which is 43.3 inches, square inches, basically. So that's the area. Next question. In this triangle XYZ, we have side XY, which is 5 millimeters, YZ is 8 millimeters, and angle Y is 56 millimeters. And now it's asking us to find XZ, this side. First of all, I named the sides as X and Y, like side X, opposite angle X, side Z, opposite angle Z, and Y, opposite angle Y, just to make it a little bit easier for myself to write the equations. Okay, so here we are given two sides and the angle between them, and we have an oblique triangle. Oblique triangle means an angle that doesn't have any 90 degrees or right angle. So it's not a right triangle. In an oblique triangle, to solve for one side, we can use law of sine or law of cosine. In this case, two sides and the angle between them are given, so we use law of cosine. How do we write the law of cosine? Y squared, y is the side that we're looking for. So I'm going to write y squared equal to the other two sides, x squared plus z squared minus 2 times x times z times cosine of angle y, which is the angle between those two. So this is law of cosine. Now I'm going to replace what I have. X was 5 squared plus z was 8 minus 2 times 5 times 8 times cosine of 56 degrees. Now I'm going to use my calculator to find it. So first of all, make sure your calculator is in degrees mode. So here you see degrees is highlighted, so it's in degrees mode. Now I'm just going to enter this to my calculator. 5 squared plus 8 squared minus, I'm going to put a parenthesis, 2 times 5 times 8 times cosine of 56. Okay. And next I need to find the square root of this value. So I'm going to find the square root of second answer. So 6.65. 6.65. Oh, I'm sorry. I needed to write this is y squared. And from here, y, when you find the square root of that, 6.67 is the measure of side y. Okay, now let's go to the next question. We are trying to match these functions, sine, cosine, secant, cosecant, tangent, and cotangent with these graphs. Sine and cosine are easy. We have learn the first thing. Sine is a function, periodic function that starts with a middle point at 0. So this looks like sine. This is sine of x. Cosine always starts with a high point, so like this one. So this is cosine. These two are tangent and cotangent. The one which is increasing is tangent of x. The one which is decreasing is cotangent of x. What are secant and cosecant? Look at these two. These are either secant or cosecant. How do I know which one is which? You just need to connect these lines, the middle point and the high points of these curves together, and you see that it's going to look like this. So this one is basically, let me draw it again, make it a little bit more accurate. Okay, like this one. As you see, it starts with a midpoint at 0 and 0. So this is because I see a sine function, a sine graph hidden between these graphs. That means this is reciprocal of sine, which is cosecant function. And for this one, if I connect the high and the low points, I see that starts with a high point, and that's a cosine function hidden between these curves. So this is reciprocal of secant. So that's it's basically reciprocal of cosine, which is called secant function. So these are the graphs of this function. Next question, a trigonometric function is shown below, 5 cosine of x plus 2, and we want to know which of these features are right. So first of all, I'm going to graph the function. We know that the 5 is going to replace for the amplitude, and the 2 here is the sinusoidal axis, which is showing the vertical shape. So the function is shifted up to here at y equal to 2, we have the sinusoidal axis. And the 5 gives me the amplitude. So I go 5 up at 7, that's the highest point, and 5 down at -3 is the lowest point. Since this is a cosine function, we start with the high point. High, middle, low, middle, high. So this will be the graph. Okay. Now let's see, what do we have? The graph has reflectional symmetry over the x-axis. If this was reflectional over the x-axis, that means the top and the bottom side of the x-axis should be reflection of each other, which they're not. So this one is not right. The domain of the graph is all real numbers, which is right because we know the function continues from the left and the right side is the trigonometric sinusoidal function. So this is right. And the range is -3 to 7. That's also right because the lowest point is -3 and highest one is 7. So that's the range. This one is right. The function has zeros at kpi, where k is an odd integer. This one is not right. Why? Because the zeros of this function are these 2 points where the graph is meeting the x-axis. And so let's look at the critical points of this function. The first one is here at 0, and then this critical point we know for the function is at pi over 2. This critical point is at pi. This one is at 3 pi over 2, and this one is at 2 pi. So these are the critical points. How do I know that? Because the b value is 1, and that means the period of the function is not changed. So the critical points are also not changing. So that's how I know. I'm going to just take the critical point of the parent function in this case. Anyway, so as you see, the 0 is somewhere between pi over 2 and pi, or somewhere between pi and 3 pi over 2. They are not multiples of pi, because this is saying the zeros could be at k is an odd number at 1 pi, at 3 pi, 5 pi, and so on. But as you see, the zeros are not any of those points. So this one is wrong. Okay, next one. A trigonometric function is given below. and it's asking us to list the transformation. So first of all, amplitude. We know amplitude comes from this A value. So we have because the A value is 7, that's going to replace the amplitude, represent the amplitude, which is 7. So basically we have a vertical stretch because the number 7 is greater than 1. So we have vertical stretch, amplitude is 7. Phase shift, that comes from this value, which is added or subtracted to the x of the function, or the angle, or theta. We are adding pi over 6. We know inside the function always acts opposite, so it's going to go left pi over 6. That's the phase shift. Okay, vertical shift. If you add or subtract a number to function, that's going to give you vertical shift, and that's this number. So we're subtracting 4. That means the function is moving down 4. The period of the function comes from the number that we multiply by the angle. And here, basically, we don't have anything. It's just a 1 here. So the period, the b value is 1. That means the period is not going to change. It's not going to be the same as the parent function, which is 2 pi. Okay, let's go to the next one. An ice cream truck that plays loud music is circling Tubby's neighborhood. C of T models the volume of the music in decibel that Tubby hears. T, which is T minutes after the truck arrives in this neighborhood. So this is the function. And it's asking what is the period of this function. Again, we know that the period basically can be found using the b value. And that's the number, I'm sorry. That's the number which is multiplied by the angle. It could be called t, x, theta. This is just the name of the variable. Okay, so we found that the b value is 2 pi over 15 in this case. Now, to find the period, you're going to take the period of the parent function, which is 2 pi, and divide it by this b value, 2 pi over 15. Since this is a fraction, I'm going to keep the first and change the division to multiple and flip the second one, 15 over 2 pi. They cancel each other here, and 15 is the period of this function. Okay, let's go to the next question. Graph of a sinusoidal function is given below, and we want to write a sine and a cosine function for this. First, I'm going to write the general sinusoidal function for you. Y equal to c plus a sine, or it could be cosine of b theta minus t. Now we're going to find all these a, b, c, d values from the graph and write the equation. First of all, c is the vertical shift, or basically the sinusoidal axis. I found the sinusoidal axis here at 2. How did I find it? If you just take the highest point, 5, and the lowest point, -1, combine them and divide by 2. 4 divided by 2 is 2. That's going to give us the midpoint. So the vertical shift is at 2. It's moved up 2. That means C is 2. A is the amplitude of the function, distance between the highest point and the middle point, or sinusoidal axis, which is 3 in this case. So A is 3. B value. To find the b value, first we need to know the period of this function. You can find it by finding the distance between 2 high points or 2 low points. In this case, the low points is easier to find, from 0 to 4 pi over 3. So the period of this function is 4 pi over 3. And we have learned before that period of the new function is period of the parent function, which was 2 pi, divided by the b value. So we have this equation and we can solve it for b. I do the cross multiple. Then from here, b times 4 pi is equal to 3 times 2 pi. Now I can divide both sides by 4 pi. And The pi here goes away. The 2 is 1. 4 divided by 2 is 2. So b is equal to 3 over 2. The last thing that we need to find is the d value. That depends on the function that we want to write. If you want to write a sine function, you need to start with a middle point that is going up, right? This one, for example. Because now, after this point, I'm going to have a sine function like this. So the starting point is here at pi over 3. That means the d value was pi over 3. So the function will be y equal to c, which is 2, plus a amplitude 3, then sine, because I decided to write a sine function. B is 3 over 2, we found it from here, and theta minus the d value, pi over 3. So that's for sine. If I want to write a cosine function, then I need to look for a high point. A high point could be this one, for example. So the function is going to be like this. This is a sine function. Okay. Now, the start point is here at negative 2 pi over 3. D is negative 2 pi over 3. I can write the function y equal to c, which is 2, plus a, which is 3, cosine of 3 over 2, that's the b value, theta minus negative 2 pi over 3, but negative times negative is positive, so I'm going to change it to theta plus 2 pi over 3. So these are the two functions. Now let's go to the next one. The terminal side of an angle is modeled in the diagram below. Which angle rotation could be represented by the terminal side in this diagram? Okay, so this is the angle rotation, and we want to know what angles it can represent. The angles could be, first of all, we know that we're looking for a standard angle. That means it needs to be started from the opposite side of x-axis, and it can either go this way or this way. So we have a positive and a negative angle. How do I find this? We have learned before that if I have this, let's say this is the unit circle, because I know the radius is 1 here, a point on the unit circle has an x and y coordinate. Then the x and the y could be basically represented here. This is the x value, negative root 2 over 2 here, and this one is the y value, root 2 over 2. These two can represent the sine and cosine of this angle. Anyway, how do I find this angle? If I find this little angle, which I can call that reference angle, then from there I can find the other sides of this angle, like this one and this one. We have learned before that if we have a triangle, here you see I have a triangle, which is 45, 45, 90. The ratio of the sides are 1, 1, and root 2. If I divide everything by root 2, then this one will be 1, and this one 1 over root 2. I can rationalize that by multiplying top and the bottom by root 2, and it's going to be root 2 on top and 2 in the bottom. So this will be the ratio of the sides. So what I want to say is that since the ratio of the sides are root 2 over 2 and 1 here, because this is the radius and it's equal to 1, so I have the ratio of this triangle, 45, 45, 90. That means this little angle, this reference angle, is basically 45 degrees. So this is what I figured out at this point. Now, what is my original angle? We know that half of a circle is 180. And if you subtract this little one from that 45, it's going to be 135. So that's this angle. So this is one of my answers. Now, 45 degrees is definitely not my answer because that's my reference angle. It's not the standard angle. Now, the other two are the angles in radian. Let's see if we can find 135 in radian. You have different ways to find in radian. One way is just multiply by pi over 180. And when you simplify that, you will see that is equal to 3 pi over 4. So that's my other answer. You could also find it in this way. So say we have half of the circle, which is pi, and this little one, 45 degrees in radian is equal to pi over 4. We know that pi over 4 is 180, is 45 degrees. So to find the rest of it, just subtract pi over 4 from that. And then I find the common denominator by multiplying top at the bottom by 4. So this will be 3 pi over 4. So this was the other way to find it. Now, let's see what is the measure of the other angle here, which starts from here and goes to this point, and notice that it's going to the negative direction. So again, here, I'm going to consider that half of a circle is pi, and I can add this little one to that to get this whole distance. So I can add pi over 4 to pi. So it will be 4 pi over 4 plus pi over 4, which is 5 pi over 4. But notice that we're going to the negative direction, so it will be negative pi over 4. So this one is also my answer. All these three are the angles that can be represented here. Okay, let's go to this question. Let me erase these for you and explain what we have here. So here we have Susie and Jack are looking at the top of this tree. Susie's angle of elevation is 36. Angle of elevation is the angle which is made with the horizontal line to look at something on top. So this is the angle of elevation for Susie, which is 36 degrees. And angle of elevation for Jack is this one, which is 36. Oh, no, I'm sorry. It's 50 degrees. Okay, this is 52. As you see, we have an oblique triangle here. Why? Because these two angles are 50 and 36, and if I subtract them from 180, it's going to be 94. That's this third angle, 94. So we don't have the right triangle, we have an oblique triangle. Also, we're given the distance between Susie and the top of the tree, which is this side, 25. Now it's asking what is the distance between Susie and Jack, this side. So I call this triangle as ABC. So this side, opposite angle, A is side A, this one is side B, and it's the one that we're looking for, and this one is side C. On a triangle, which is oblique triangle, we have one angle and the opposite side, and we have another angle and we're looking for the opposite side. We can use the law of sine here. What is law of sine? This is law of sine. Sine of angle A over side A equal to sine of angle B over side B equal to sine of angle C over side C. Since we're not looking for side C, we can ignore this part and just look at this side, okay? And replace what we have. Sine of angle A is sine of 50, side A is 25, sine of angle B is sine of 94, and side B is what we are looking for. Now I can cross multiple and solve for B. I'm going to write that here. B times sine of 50 is equal to 25 times sine of 94. Now I'm going to divide both sides by sine of 50. And then I can have the B value. Okay, let's go to the calculator. Make sure your calculator is in degrees mode. So 25 times sine of 94 divided by sine of 50, which is 32.55. So 32.55 is the other side that we were looking for. And it's basically the distance between Susie and Jack. Okay, let's go to this question. I'm going to erase these and oh. Okay, Tony and Billy are standing at the same point. So let's say here we have Johnny. Johnny is here, and Billy is also standing next to him right here. Here are the directions: north, south, east, west. Johnny walks 13 feet to the east. So let me draw that for you. 13 feet to the east, and then 5 to the north. So here, 5 to the north. This side is 13, and this is 5. And then we have the next one. Billy walks 8 feet to the east. So let's say here, 8 feet to the east, and then 3 to the south. So something like this. This is 8, and this one is 3. Now, using the start point, right, this point, as the vertex of the angle, find the positive acute angle formed between Johnny and Billy. So Johnny is here, Billy is here. The angle which is made between them can be represented in this way. You see this one and this one. So we draw a line from the vertex to these 2 points. Now, what are we looking for? We're looking for this whole angle, which is between these 2 people. If I find the angle which is here, let's call that theta 1, and this angle theta 2, and I add them together, I can find the angle between these two. So look at the first one. I have a right triangle, and I have opposite and adjacent side. And we have learned before that tangent of theta, well, in this case, we have theta 1 equal to opposite over adjacent, which is 5 over 13. Now, to find angle theta, I can use the inverse function, tangent -1 of both sides. These two cancel each other, and theta will be tangent -1 of 5 over 13. So I'm going to use my calculator. Second tangent, that's tangent -1 of 5 over 13. 21.03. 21.03. That's theta 1. Now, to find theta 2, again, we're using the same thing. Tangent of theta 2, which is this angle, is opposite over adjacent. That's 3 over 8. Again, to find theta 2, we use the inverse function, tangent -1 of both sides. These two cancel, and then theta 2 will be equal to second tangent of 3 over 8. 20.5 or 55. That's theta 2. Now the whole angle theta is theta 1 plus theta 2. 21.03 plus 20.55. Okay, so it's going to be 8, 5, 1, and 4. So that's the angle between these two. Okay, let's go to the next one. Consider the first wheel below as a unit circle with seat A in 0 degrees. And now if the first wheel rotates 135 degrees, what will be the height of seat A above the ground? Okay, so we have learned before that on the Ferris wheel, if we consider one point on the Ferris wheel, it's going to circle around here, and the height of this point at each time is basically a function of the angle that the point is making here around this circle. Like if this point moves here to this point over here, then this angle, we call that theta. Height of this angle, height of this point is basically a function of the angle which is made here. And that's a sine function because height is going to be the y value of this point, and we have learned before that if we have x and y here, y is the sine of this angle. So the function is y equal to sine of theta. However, as you see, if I consider the coordinate plane here, this point, which is a 0, angle 0, is basically starting from here, which is a little bit above the ground. So the function is basically shifted up a little. How far it's shifted up? Okay, this circle has diameter of 3 meters, and this little space here is 0.5 meters. Half of 3 is 1.5, so this is 1.5 plus 0.5 is 2. That means this whole distance is 2. So my function is shifted up 2. So to write my function, I'm going to write plus 2. Now, the question is asking what happens, what is the height of this point if it's making 135 degrees? So let's say, for example, 135, let's say is almost here at this point. Then what is the height? Okay, all I need to do is to replace the 135 here in this equation. Sine of 135 plus 2. You can use your calculator. What is sine of 135 plus 2? It's equal to 2.70. 2.70. And it makes sense because I know 135 is almost here. This distance is 2. Like from here to this point is 2. And a little bit above that, where it's almost close to the highest point, it could be 2.70. So it makes sense. Okay, so that's how you find the height. Now let's go to the next question. This one is also similar to what we just did. Consider the water wheel below as a unit circle with point A at 0 degrees and 3 meters above the surface of the river. So let's say this is surface of the river here. So we also consider our coordinate plane here. And at this point is 3 above the surface. Anyway, the distance of the point A from the surface of the river is the function of the angle of rotation of the water wheel. So similar to what we just talked about, as this point is making its way on the unit on the circle, is circulating around here. The height of this point is basically, the height of this point is basically a function of the angle which is made with this angle around this circle. So like, for example, here, if I consider theta, the point A moves here. So this height is a function of this angle. So again, y equal to sine of theta is the function, because we know that this point has the coordinate x and y, and we learned that the y value is sine, and y value is what we are looking for, the height. But notice that it's shifted up for 3 meters because it says this point is 3 meters above the surface of the water. So whatever is this point, I need to add 3 to that. So my function is sine of theta plus 3. Okay, so at each time, if I want to know what is the height of the point, I just need to find the angle. Let's say, for example, similar to what we did before, if my angle is here at 135, then I just plug that here. So it's going to be sine of 135 plus 3. So I can use my calculator. Sine of 135 plus 3. This time will be 3.70. Okay, 3.70. That's the height. I could use any other angle as well. Let's say sine of 225. Okay, so sine of 225. That means if 25 is here, then what is the height of this point? So the point is going to be here. So let's say what is the height in this case? So I'm going to use my calculator. Sine of 225 plus 3, it's going to give me 2.29. So it's almost, well, of course, this is not very accurate, but it's going to be 2.29, which makes sense because it's below the sinusoidal axis. It's somewhere below that, so it's going to be less than 3. That makes sense. So that's how you can find the height of the point at each time. And the graph of the function could be something like this. Y equal to 3 is my sinusoidal axis. And then the highest point in this case will be 6. The lowest point is at 0. And the function could be something similar to this, that it's repeating itself because the point is making circles around this circle, this water wheel, for several times. It's just repeating itself. So the function is also repeating itself. So for this question, you need to explain this relation, say that it's a function like sine of theta, which is moved up 3, it's repeating itself, and the angle which is made is going to give us the height at each time. And this is the graph. Okay, that was our review, and have a great day.